The digital technology has made possible that we can transform the projection at our will. So that's also an important advantage in the digital technology when we represent the spatial information in the form of map using specific. So in our previous session, we discussed about map as spatial representation. In this session, we looked into its characteristic and features, um, which, which are so important for all of us to understand. In the previous session, we also looked into the characteristic features of map, and we also looked into the various types and highlighted map elements also. Now, in this discussion today, we would highlight map orientations and also projections, the importance of map orientation, directions, and also the importance of projections. Because if you recall, we mentioned that projections are very important and critical for representing the ground phenomena in a flat plane paper or two-dimension screen. So for that matter, we need to make some adjustment, and these adjustment based on certain specific mathematical and statistical principles, we are making we are using the projections, appropriate projections, to represent different part of the earth or the whole of the earth, which is in spherical shape, and we are bringing it into the two-dimensional flat plane. So in this particular discussion, in this particular session, we will also highlight their significance of projections and also the direction in spatial representation. Projections. The spatial representation have evolved with time, where orientation changed with time, as I have already explained to you. This map orientation is very important and critical. Maps are usually created from the perspective of a particular direction. And as I am saying that traditionally we use north in upward direction in any kind of map preparation. But this directionality of a map is known as its orientation, and the importance of orienting maps towards the north was a reflection of where the magnetic north of Earth exist. Traditionally, as I am saying, that north always tend to be towards the top of the map and south towards the bottom. Aesthetics, political interests, egotism, and navigation are some of the other reasons where the spatial representers use different map orientation. And I'll give you some example of it. This is a very early map of which is being said as prepared by Ptolemy. It is notable for being the first to use longitude and latitude lines, as well as specifying terrestrial locations of the known world at that particular period of time. So it is only confined to the Central Asia and area around the Mediterranean Sea. This was the early map which Ptolemy has prepared. Now, in this particular map, the orientation remained as the same, where north is pointing towards upward. Then you see, this is another interesting example where European cartographers oriented their maps towards the Holy Land of Jerusalem. These maps are known as the East-oriented Mappa Mundi, the medieval European world map, which is also known as T and O maps, which was symbolic representation of the world. O representing the boundary of the world encircled by the Earth's oceans. So the landmass was surrounded by oceans, and this was represented by O. The T nested inside the O divided the world. The northern hemisphere had 3 continents in this particular map, if you look minutely. Asia at the top, Europe to the left, and Africa to the right. The southern hemisphere was ignored because it was mostly dominated by water body. So the horizontal bar of the T represented the Mediterranean Sea, and the vertical portion of the T, there they have highlighted the Nile River and the Don River. So that is where I would again say that the known world of that particular period of time, and also the areas which they wanted to highlight, these have already been highlighted in this particular map. Another is, in the context of orientation, there were also maps which were west direction oriented. This is an example where a map of Netherlands and New England in Europe, prepared by a Dutch cartographer. It is represented where west direction was highlighted in this particular map. Another map which has south orientation. Now this is again interesting that the south has been highlighted, the south pole has been highlighted, and it is altogether switched to another direction, where these south orientation maps, it west towards the right and east towards the left of the map. It was prepared by a Moroccan cartographer. All in all, I would say that this is how the earth or world is existing, and we need to depict this kind of spherical shaped earth onto two-dimensional flat plane. So here projection, direction, orientation and scale, they are integral to present this way the spherical map, spherical earth over the two-dimensional flat plane in the form of maps. So on flat plane, it is represented like this, as only one side can be shown on two-dimensional representation. So you can see that there are two globes, two maps are being represented. One is representing one side of the sphere, and the second one, the right one, is representing the other side of the sphere, which normally we won't be able to see if you look into the globe, but it lies on the back side of the globe. But we try to represent all these continents, all these land masses in one flat plane. So that is where I would say the use of projection is required in our preparation of spatial representation in the form of map. So here we require projections. Here let me appraise you that this is very complex process, but in digital mode it can be done, and as I have said that it can be changed and transformed also only with a click of the button. So map projection is a necessary step in creating a two-dimensional map of a three-dimensional spherical earth. A set of transformations are employed to represent the two-dimensional curved surface of a globe on a flat plane. In a map projection, we require coordinates. We are splitting the whole of the earth into certain grids, and these are known as the coordinates. So it can be latitude, the horizontal lines, and longitude, which are the vertical lines. So they form a grid and they are spread all over the globe, transforming the surface of the globe to coordinates on a flat plane. The choice of projection depends on the purpose and use of spatial information. So all projections of a sphere, that is the three-dimensional representation of spherical earth on a flat two-dimensional plane, necessary. It is when we try to do this, they distort the surface, and map properties and possible there can be different kind of distortions which are possible in a map. These distortions can be in the form of area distortions. Some areas might be appearing large and some areas might be represented as smaller than what their actual size over the earth's surface, because of the certain kind of selection of projections. There might be distortions in the shape also, and also direction, where the choice of projection may result into some kind of distortion in the directions and also distance. So it is very difficult to preserve all these features. So any projection which we adopt, there might be some errors would be existing into it. So different projections preserve some of the characteristic of the spatial information in two-dimensional flat plane. But in all these representation, we have to compromise, and we have to we have approximate basic properties in different ways. So what happens, we select a certain projection depending on the area which we want to represent, depending on the spatial dimension of any specific phenomena in which exist over the Earth's surface, and we make compromise. We highlight some portion which is relevant, and we let distort to other areas. The distortion may happen in other areas. So we need to make some kind of compromise in selecting the map projection, because as I am saying again and again, that when we try to represent the spherical Earth over the flat plane, there is bound to happen some kind of distortions, despite of the selection of any of the projection which we want to take. And as I am saying, that we choose projection on the basis of what is our purpose and utility, and which area we want to represent in any specific map. So now I would try to explain what I have already said to you with the help of some maps which will give you an idea as to what kind of distortions I am talking about. Now here the world is depicted in different way, and some interesting fact which I would like to share with you. This is a very general kind of cylindrical map of the Earth, where you can see that there is North America, South America, Africa, Russia is appearing quite large, Greenland is appearing quite large, and there are many other countries where India is also figuring in the Asian subcontinent. So this is what we perceive as world, and the land masses and the continents, they are existing over the Earth's surface. But actually they are not like this, because again, if you put it on a ball, as the Earth is spherical in shape, then you would find that it cannot stick up, and it cannot take up the surface of the entire ball or spherical model which we see in any globe. And when we represent it in two dimension, as I am saying again and again, that it may create some kind of distortion, and that I would like to show you. So here you compare Africa and North America and Greenland and India. They all are having relatively different proportion. Now very interesting, I would say that we can fit Africa into USA, not only USA but also India, Europe and China. That large is the continent of Africa. But we feel that Africa is almost equal to, say, North America, but actually it is not. You see, here I have tried to jigsaw fit all these land masses, all these countries into the continent of Africa. So Africa is quite large, because two of the largest country like United States of America and China, they are fitting into it. India is also fitting into it, and Japan is over the Madagascar, and Europe is also coming in between within the continent of Africa. So this large is Africa. But if you look into the map, it appears that Africa is almost equal to USA or Russia. And if you see in any cylindrical map, you would find that Greenland is almost equal to Africa, whereas it is not the case. Then I have talked about Greenland. So it looks as in a map which I have shown you, it looks as big as Africa, but actually it is only 1/14 of the size of Africa. So if I can bring the Greenland over the Africa, you can see on the right side of the image how big is Greenland in terms of area. It's very interesting. So you see, and if in this cylindrical map, you can see the size of North America and Africa, the size of Greenland and Africa, and if I can bring India over to Africa, it looks like this. Where, because the distortion is lesser, because both of them, they are close to the equator, so the distortions in cylindrical map is lesser around the equatorial region. But if I can bring India and Greenland, because in cylindrical map the distortions of shape and area is much prominent when we move away from the equator. So India is actually larger than Greenland, and if I can take India to over the Greenland, the shape would distort in this particular cylindrical Mercator projection. The shape would be distorted like this, and it will be as large appearing as the Greenland. This is and if I can take the whole of India over Europe, it will appear like this. So this is where I would say that these kind of distortions are possible and happen when we bring the three-dimensional Earth over the two-dimensional flat plane. If you take if you continue with the Greenland example, in terms of area, India is substantially larger than Greenland, but it appears there as big as it's much bigger than our country India. So that kind of distortion I wanted to highlight, and we cannot ignore them. We do ignore them, but you see, we have to bear with it, because whatever projection we select, these distortions would exist. Here it is on the basis of size, but there might be many other distortion in terms of area, in terms of direction, in terms of scale, etc. So in a cylindrical map, which is very commonly we see all the time, you see that how the distortions are taking place. The same size of circle near the equator, it enlarges and get distorted as we move northward or southward towards the poles. So the distortions in these cylindrical map would be far more at the pole, and at equator they would be more appropriate. So these are the relative distortions. So whenever coordinates are transformed, these three-dimensional angular to two-dimensional planar coordinates spatial relationships are distorted. The adjustment is made in the placement of standard lines. So what we do, we select some areas and we try to preserve and restrict the distortions along standard lines. We may take specific latitude or longitude, and that way we try to prepare smaller area representation using certain projection. So as I am saying that the adjustment is made in the placement of standard lines, we can make here our choice comes into the picture. The central meridian can also be taken, and to shift the amount and type of distortion across the projection, we select accordingly the standard lines and the latitude and longitudes. Some common type of projections are, for example, azimuthal. They preserve directions from the center to any other point of the plane. The conformal, they preserve the angular relationship across the projection. The equal area or equivalent area projection, they preserve relative area across the projection. And equidistant projections, they preserve distances from one or two specified point on the flat plane. So it depends. If we have to more appropriate scale is required, then we would use the equidistant projection. And if we want to protect the area, then we will go for equal area. So azimuthal would be preserving the directions. So that way the choice of projection depends on our purpose of representing specific area over the Earth's surface. So the projection surface, as you can see here, the flat plane, the spherical Earth is represented on flat plane, and our surface can be unfolded and unrolled into a plane or sheet of paper without stretching, tearing and shrinking, and it is called as developable surface areas. So when most of the time we are giving you the example of cylindrical projection. So you see this cylindrical projection and the distortions which are happening away from the equator in the size, in terms of size and area, is very visible, because that is how we develop the spherical surface onto the flat two-dimensional plane using the cylindrical projection. This is how we can prepare map with cylindrical, cone, plane, and this is how the area is represented in different type of projections, using cylindrical projection, using cone projection, and using the plane projection. The earth can be projected in many ways, but basically onto three shapes that can be unrolled into flat plane. It can be, as I am saying, a flat plane, a cylinder, or a cone, and they would be appearing like this, as the right side of it right side of the presentation is displaying. So cylindrical is the whole of the earth is represented in the cylinder shape. Conical is cone can be put over a specific area, and then it is unrolled and developed over the two-dimensional flat plane. This is how the projections are being used and prepared. And as I am saying that no projection can preserve everything, it cannot ever depict the spherical shape earth onto two-dimensional flat plane. These errors would always remain, but we have to make adjustment into it depending on the purpose and the utility. A projections case referred to how this surface was positioned on the reference globe. For example, if the developed surface touches the globe at any one point or line, it will be known as the tangent projection, and if it touches two, then it is known as the second projection. So if it is touching at two lines, so the distortions would be lesser along these two lines. So that is how we prepare maps of a larger area. These are some examples of common projections and their properties, and also the application area. For example, Albers equal area, they represent small regional and national maps where area is being preserved along the standard parallel. One very common projection type is known as the Mercator. The example I have shown you earlier also. This is conformal and true to its direction. Most of the navigation is being done using the Mercator projection. It is equidistant along standard parallel, that is equator, and central meridian, that is 0 degree longitude. Mostly it is being used for navigation and representing world maps. Mid-latitude areas with east-west directions, they are more appropriately not being represented. In atlas mapping for smaller countries, it is being used. Then conical, polyconic and conical map projection are also being used. In our country, all the topographic maps are used or are being prepared on polyconic projections. It is equidistant along each parallel and central meridian. So all in all, I would say that it depends on the purpose for the selection of appropriate projection. Projections are very important and necessary. Why? Because we need to bring the spherical shape to the flat plane, so we require some projections, some kind of projection, but none of the projection can give you can preserve all the properties of the earth spatial representation. That's an interesting point and very important point which you need to remember. But there are some other ways of representing. For example, in modern day, especially when we are looking into the spatial representation in digital format, uh, in modern day, mostly we use the UTM coordinate system. It offers the benefits such as they are being represented in a square grid UTM. It provides a constant distance relationship anywhere on the map. And UTM coordinates are measured in metric system. That is also very important advantage of this particular projection. And it helps in complex spatial transformation because it is constructed in metric system. Now what happens here in UTM projection, there is 6-degree latitude and 6-degree longitude spatial extension is being represented by one grid, and the entire earth is represented in horizontal position. It ignores the altitude and treats the earth as a perfect ellipsoid, and it divides the earth into 60 zones and projects each to the plane as a basics for the coordinates. So this is what the UTM projection, which we in digital mode spatial representation use a lot when we are representing relatively smaller area. So this is what about the importance of projection in representing the spatial information.